Hello, everyone. Welcome to linedevday 2021. It's nice to see you all here. My name is Zhixin Li. I'm a server-side engineer in CSI Dev B Team and also Home Server Dev Team, which is a server-end development of Line applications home tab. It's my great honor to have a talk about a versatile system for delivering information to the Line home tab. About the topics I'm going to talk, I will start at what is Line home tab and the recommendation component inside. Then, how we implement this delivering system, about the system architecture and the technology we used for it. Next, we want to be focused on the server challenges we encountered and the strategies to conquer them. Finally, I will have two successful use cases to show the power of this system. I think you maybe already know about Home tab. It is located on the first tab of Line application. There are some important components here, including the user profile, the setting, the notification, which is a bell icon, the friends groups you have, the service list that gathers a lot of Line services and some third-party services that user can customize them on the Home tab. Under the service list is today's topic, the recommendation content. User can get various of recommendation contents. For example, for Japan user, we have the recommended stickers, the free manga recommendation, open chat, and some special campaigns. Also, we have Line Music, Line Cosme, and lots of other contents if you open the Line app to check them. But not only we have many contents, the layouts are all different. As you can see, the sticker one, we have a round image with a title. And for the manga, the ratio of the image is different. Also for open chat, we have a round image and also the group name and group member information. How can we create this content in a different layout? So as a common flow to create recommendation contents, we usually have three steps: design, development, validation, and release. In the design step, our designer makes the UI for the recommendation based on the trend and the feature of that. And in the development part, iOS, Android team members implement the UI in the client version, and home server is an API server for client will add the response data to the API. Data provider is the upstream server of home server. They are using the machine learning suggesting technology to give the recommendation data for each user. They need to implement the recommendation API for each content. And the Smart Channel is an internal service for personalized recommendation of Line. And we will use that for most regions. After all development part implemented, finished, the QA member will help us to validate the UI, the targeting, and the content information. And business planning team will decide the final release date. From the common development flow, actually we can find some drawbacks of it. The first one, the development cost is quite high for new recommendation contents, because for every content, it involves 3 different development teams, and we need to repeat it for every content. Second, the development release cycle is slow. Because we implement the UI on the client side, the new content require a new mobile application version. And third, therefore, it's also impossible to make a UI change for released content. My question would be, how can we overcome these drawbacks and make the system more versatile? Before talking our implementation, I would like to list some requirements of the system. The first is versatile. Of course, it's also showing on the title. This means we do not want a hard-coded UI on the client side. If we can do that, we could release new content without new client version. Next is to reduce recurring cost. In our new system, we want to eliminate the client development cost and also try to just do a minimal home server application development, like the basic configuration only. Next part, since Line has a global users from all over the world, we want to support a server-side multi-language text support for that. If we can implement all the requirements and meet the 3 conditions, we could be simplify the development flow to just like this. After the designing, we have only the one development of the data provider. And after that, we do the validation and the release. Then let's go to the technology we applied and the system architecture part. The first thought of the technology we want to use to avoid a hard-coded UI was Flex Message. You maybe know the Flex Message is an external feature for Line Message. Official account can send such message by Line messaging API. The Flex Message is a JSON format text that enables to arrange layouts as desired. The layout can be changed as we do with HTML code, and each component is neatly displayed. Like here, official account using Line bot to send a Line Flex message, and after the client received it, it has a built-in Flex message rendering engine, and finally user can get the actual render result. For example, the Brown store receipt or Brown cafe message card. However, the only Flex message JSON doesn't fit our needs as a home tab recommendation content format. We will talk about the detail of Flex message change later. Now, I would like to introduce the flow of the recommendation system. When a user opens Line application, the client requests the recommendation data from home server. The home server, of course, doesn't have any recommendation data. It asks the upstream server, which is a data provider, to get the raw recommendation data. After getting the recommendation data, the server will generate a Flex JSON. It's kind of similar like the Flex message, but fitted for the home version. We call this step server-side templating. And the server responds the Flex JSON to the client, and it can render the final Flex JSON result to the user. Let's take a closer look at the details of the flow. Here is an example of the response from data provider. We can see it has just the type of the content and the list of each item, including the title, the image URL, and also some link URL and other information. Based on the type here, we predefined some Flex template inside the home server. The Flex template is a JSON-like text, but it has some placeholder parameter inside. You can imagine the Flex template as a UI with just empty title and image and main title as a placeholder to be filled. Combined with the actual data, the server injects this data into the Flex template and generates the final Flex JSON. For example, here, the Moon and James title will be replaced to the title parameter here in the Flex template and generate the final JSON one. After the client gets the final generated result, it renders to the actual client UI, like what user can see here. And then allow me to introduce more about Flex template we shown in the system flow. The Flex template is an adaptation of Flex message. Compared with the original Flex message, we add many features to fit home tab recommendation, both server and client side. For the server side, to support the internationalization, we add localized text feature, parameter substitution, and server-side property customization. As for the iOS and Android side, we also have the Line theme and dark mode color matching. Then to show the user profile, we have user profile and name displaying support. Also, the Flex template will have some new layouts like non-bubble one and vertical list layout. Here are some examples of the feature. We define the special parameters for the localized text here, like hometab.recommend.comment see more. Based on the actual user's request language, the server will choose a proper language text here, like we can get see more in English, Japanese, or Chinese, for example. API parameter substitution. As we talked before, we define some parameter as placeholder here. Server takes information from the API response and puts them into the template during the intermediate templating stage. And we can get the actual title from the API response of the upstream provider. And server-side property customization is another feature. This allows us to control some properties on our server side. We save the customized property to our database, and it's not from the API response. These parameters will be filled during the intermediate server templating stage. Like the CMO URL we want to manage on our side, and it will be replaced to different configurations based on the type of the recommendation data. And last one is the color matching. On the client side, we define some color key for each theme. Like for the placement title, we use primary color. And we also have some other keys like secondary color. Based on the configuration of the client's theme, like dark mode, a lighter theme, or another theme, you can see the color are quite different to match the theme itself. After going over the system flow, we still have actual server challenges during the implementation. This is the home tab statistics currently. We have about 56 types of recommendation content. The server request usually about 25K per second. And we offered about 50 million content per day, like each sticker, each music, theme, or open chat. The server traffic is not low. We need to handle some high traffic scenario, and it's a problem if the user cannot get recommendation data anytime. So we introduced some load control strategies. They are expiration control, server fallback, retry control, and caching. We released the Japan user for this system last year, and we found sometimes user will access home tab at the same time, for example, after earthquake. And this time server has too high load and it cannot respond each user about the home recommendation. Therefore, we gradually add these strategies to avoid these things. Let's introduce each strategy. Expiration control. This means the server can control how long the client will wait before it requests the next new recommendation content. So with each successful response, the server will include a timestamp for expiration in the response together with the successful JSON. The client expires and requests new contents based on the timestamp. We use 1 hour as the default time, so each content will show for 1 hour, but we can control the timestamp based on the traffic of the server. Server fallback. This means when server fails to get recommendation from one primary data provider, we will use a high reliability data provider as a fallback. Sometimes the main provider has a temporary network issue or some new user, there's no personalized data. In this time, we will fall back to a high reliable one. It doesn't have such personalized data, but reliable enough to always give some data. Since Smart Channel has better contents, we will choose that as always as the primary provider. And then retry control. In some cases of failure response, the server can control how long the client waits before it retries next request. When a server-side error happens, like a network issue or internal server error, the server will add a timestamp to the failure response. this will be used by the client to decide when to retry. And in the case of the request timeout, the client uses the default one inside. So if the server fails to get, we will use, for example, retry after 1 minute. If after 1 minute the server resolved from this error, it will give a successful response with expiration after. The next one is caching. The server has a local cache for template data. This is used to reduce time spent on the database request, as well as processing time for server-side property customization, because the content-specific property can be processed beforehand. At last, let's look at 2 examples using the system. The case 1 is personalized recommendation data for Taiwan users. We released this high personalized content to Japan users last year. And we also add Taiwan users to the scope of highly personalized content this year. We developed and released in 2 months to support about 15 types of contents. And during the process, they are on a minor home server and client dev effort. Here is the whole schedule of the Taiwan release. You can see we use a lot of time for the personal data provider development, and configure QA released just occupied half of the time. But if we use UI in the front end, it will take much longer than its implementation. And case 2 is campaign content delivery. For some special situations like holiday contents, we may want to provide some static content for all users for just a short period of time. Using our system, we also implement a feature that allows us to provide this content with flex template. Therefore, we can reduce the data provider depth to 0. For example, we'll give some special recommendations based on the holiday. And we could also configure the contents to override the normal recommendation, of course. And in the future, we will give more better and intriguing recommendation content to our user using this system. Thank you for your participation of this session.